All right. Make sure this is off. Okay, January 14th, it's activity day today. So, in yesterday's lecture, we talked to you about what they would refer to as vector resolution, which is taking a vector that's given to you in polar coordinate form with magnitude and angle and rethinking it as two vectors that are perpendicular to each other, one that is referred to as the horizontal component and the other that is referred to as the vertical component, kind of being added together tip to tail. And if you're still not exactly sure, well, why do we do this? Hopefully after we get through this whole unit in the next few days, you'll go, oh, I get why this is necessary. So today, the assignment is going to be to take all 10 vectors of your master list and break them into their horizontal and vertical components. So starting with A, this is what I would like you to be doing on this paper. From your master list, copy down the magnitude and direction that was given to you, and then I want you to make a quick little sketch. It does not have to, you don't need a protractor for this, you just have to give me a quick sketch of, well, what would A look like? And the bigger deal is not so much the 4.9, but the 31. Because 31 degrees, if you want to, you could always put a tiny little coordinate system just to kind of say, okay, this is where I'm viewing my coordinate axes as being. And then you could draw a vector that would kind of go off in that direction. Again, you don't need a protractor. You know, I think you can eyeball 30 degrees or so without making it too crazy. Now, what I would like you to do is label that one with the letter and the arrow, but then what I would like you to do is to draw in the two components into the picture. And usually, the way this is traditionally done is you draw the horizontal one first, and I'm going to do this in a different color. You do not have to, but just so you can see what I'm really looking for. A horizontal component would point over that way, and the vertical component would be like that. And this horizontal one would be AX, and the vertical one would be AY. Now, do not worry if these point technically in a negative direction. You don't put negative in front of it, either one of these. You just call them the vector sub x or y. The sign will come into play when you do the calculation. Once you've made this little sketch, then what I would like you to do is to resolve this vector into the two components mathematically, which for the x component, this would be the magnitude times, what's the trig function that goes with the horizontal component that we learned yesterday?
Cosine.
Cosine. The cosine of the angle. And then I want you to give me the final answer for this calculation. And remember, it should have units on it. And this number, round it to the nearest hundredth, okay? And then below it, you're going to do the same thing to calculate what the vertical component is. How is it close to, but not exactly the same? What's the only thing we have to shift from this to make it this? Thomas? It's sine instead of cosine. Everything else looks exactly the same. So if you're asking me, why do you make us copy down this stuff? It's to drill into you this idea. If you're attacking the horizontal component, you think cosine. And if you're doing the vertical component, you use sine. And I'll draw this down, and that will also be rounded to the nearest 0.01. Okay? And when you're done with this, you go to B. And you do exactly the same thing for B. But your picture might look a little different because it's going to point in a different direction. And remember, do not get into the math thing about, well, let me look at the reference angle. No reference angle. Use exactly the angle that you've been given. What was the benefit you get from that? Anybody remember? It will give you the appropriate plus or minus sign automatically. And you don't have to sit there and go, wait, this is in the third quadrant, so the horizontal needs to be negative and the vertical needs to be negative. If you use that third quadrant angle in your calculation, those negatives will automatically be part of your answer. Okay, are we good with this? Okay, so you guys have the rest of the period to work on this, and we'll kind of see how things go. I'm willing to extend, time to the next period because I would like this to stay here. And for all of those in video land, you can do this one at home. So you are not exempt from this because you are not here. So you can do the same thing everybody else is doing. All right. Have a great weekend.